In this lecture, we are going to discuss about orthogonal system. First is definition of orthogonal system. Two families of curves are said to form an orthogonal system if they intersect at right angle at each of their point of intersection. If two families of curve intersect each other at right angle at each point of intersection, then the families of curve are said to be in orthogonal system. Next is a theorem. If fz equal to u plus high v is an analytic function of z equal to x plus high y, prove that the families of curves uxy equal to c1, bxy equal to c2 are orthogonal to each other. Where c1 and c2 are parameters. Given fz equal to u plus high v is an analytic function of z equal to x plus high y, the families of curve represented by u and v, we have to show that family of curve represented by u and v are orthogonal to each other, where c1 and c2 are parameters. Next, proof. Fz equal to u plus high v is an analytic function therefore it satisfies Cauchy-Riemann equation. Therefore del u del x is equal to del v del y, and del u del y is equal to minus del v del x. Put this equation 1. The given system are what are the given family of curve? That is u equal to uxy, and it is equal to c1, b equal to bxy, and it is given by c2. Put this equation 2 and equation 3. Now differentiating 2 and 3, we get, if we differentiate 2, we will get u is a function of xy. So first partially differentiate u with respect to x, then dx, again differentiate u with respect to y, dy. In the right hand side, it is a parameter, it is a constant, so it is 0. This implies dy by dx is equal to minus, if I keep it here and take it to right hand side, that will be del u by del x. Then again I will take this dx here, it will be minus del u by del x divided by del u by del y. Okay, next again, if we denote this by m1, that is slope of the first curve, first system of equation, then again differentiating second, that is del v by del c, del vxy equal to c2, vxy equal to c2, that is a differentiating equation 3, we will get del v by del x dx plus del v by del y dy equal to 0, as v is a function of vxy and it is equal to the parameter c. So to differentiate v, we have to differentiate v partially with respect to x, then dx plus partial differentiation of v with respect to y dy. This again implies dy by dx is equal to, similarly this one, like the previous one, we will get this one equal to minus del v by del x by del v by del y. Okay, and put this m2, where m1 and m2 are slope of the first and right, where m1 and m2 are slope of the curves given by represented by equation 2 and 3. Now check out what is the value of m1, m2. So this m1 is my minus del u by del x divided by del u del y. Minus del u del x divided by del u del y. Then again put del m2 is minus del v by del x, del v by del y, minus del v by del x, del v by del y, then which is equal to this del u del x is by using equation 1, that is shear equation, it is del y and it is del u del y. So here it is del u del y, this is del v del y. So this cancel out, this cancel out, this is cancel out. Here you also write using equation 1, that is your shear equation, and this implies your m1 m2 is equal to minus 1. Since product of the slope of two curve is minus 1, therefore given family of the curve cut each other at right angle, hence the system u equal to c1 and v equal to c2 are orthogonal system, With that, I would like to conclude. Remaining will be in the next lecture. Thank you.